So today we're going to be talking about, you can see at the top, what's called undefined terms, and then some definitions, some terms you already know, and then we'll look at the notation. Maybe the most important thing that we're going to be talking about today is the notation. You will need to know these definitions, but we're going to be building up toward those, and we're not going to get through all the definitions today. So let's start with the undefined terms, because that's going to be the thing that's definitely new for you. So the terms themselves are not, but just this idea of undefined. We'll talk about why they're undefined in just a minute. But let's just start with the first one. The first one we have is a point. Now you know what a point is. All these terms on this page, you know what they are. I mean, you might need a reminder, you might have forgotten, but you've seen all these terms before and you know what they are. You could draw one. But let's think a little bit more about what a point really is. The next kind of column over it says dimensions. So how many dimensions do you think a point has? 1? 0. There it is. 0 dimensions. Now remember, a dimension is how many ways can you measure the length? How many ways can you measure this point? But a point really doesn't have any measurements at all associated with it. It's defining a location. So if I have my hand up here defining this point right there, there's no height, width, depth to it. It's just referring to that particular point in space. So this is when we'd say it has 0 dimensions. All right, and we're going to do a geometric construction real quick. It's going to be your very first construction of the year. We're going to construct a point. So right here under diagram is going to blow your mind. I'm going to put a point right there, and I'm going to label it A. Here you go. I know. Okay, so we always label points with capital letters, and generally speaking, it doesn't matter what you pick, unless you're told to use a certain letter. Okay, notation for this. There are going to be times where either you are writing down some instructions for someone else to follow, or in a lot of cases, you're reading some instructions and you need to follow them. If they're referring to a point in those instructions, or you're trying to write out which point you're talking about, all you need to do to refer to it is just write the letter. You don't have to write the word point A. If you just say connect A to B, it's understood, connect point A to point B. All right. So I'm going to draw a point up here real quick. All right. Let's make sure you're paying attention. All right, so I'm going to draw a point up here real quick, and I'm going to imagine that I could grab this point and kind of stretch it out and then lay it down. And what have I created by doing that? A line. Okay, so again, not a new term for you, but this right here, this is a line. This is your second undefined term. And how many dimensions does a line have? 1. Okay. So with a line, and I'll just draw one right here, and I'll erase it before long. But with a line, I can measure any length along there. So there you go. That's what you can measure. The width of that line, the depth of the line, doesn't really exist. So just one dimension. Okay. And the diagram. We're going to draw a couple of lines here. So if you need to go into the margins to do this, that's okay. But I think a lot of you can squeeze this in. So maybe you've got a couple of points on this line, and they are A and B. I'll just stick with A's. Okay. There's A, and there's B. Or maybe you've got another line somewhere in a diagram, and they don't even have points on it, and they just have this lowercase m right next to it. And it's always going to be kind of italicized when you see it like that, but it's okay. There's a lowercase m right next to that. So now we need to come up with a notation for this. Does anyone remember how you would do a shorthand name for a line? Because one thing you can do is you can write out line AB, something like that. But there's a shorthand way of writing that. What's that? No, it's not like that. I'm going to go ahead and get you started. First of all, you're going to have to put the AB right there. What other symbol would go there?
QC.
Do you guys remember writing anything on top of the AB? Draw a line over the AB. Okay, and it's stuff that you guys have done. You just...
Oh, wow.
It's been a while. So there you go. There you go. That's line AB. Does this have another name? Do you have an idea? Line BA. Good job. It's Nick. Did I get your name right? Is it Nick? Okay. So there you go. You could also call this line BA. So the one takeaway here is that the order of the points doesn't matter. In fact, if I had like 5 points on that line, would it matter which two I picked? Or let me just give you this example. If I added a point C right here, does it matter if I call that line AC or AB? No, it doesn't really matter. Sometimes we might prefer one for certain reasons, but it doesn't really matter. I'll go ahead and get rid of that. Okay, the other way we could refer to this, when you see a line just with that lowercase letter next to it, it's not referring to any specific point. It's just talking about the line in general. So we could also just write that as line M. And you'll see that from time to time, but you generally won't be writing that yourself. You just need to recognize it more than anything else. Okay, so points and lines. Now let's take this and let's imagine that I could take this line. I've got this line drawn on the board. I'm going to imagine I could take it, I could like stretch this out and lay it down. And what have I created? Now this is an infinite thing stretching out. Does anyone know what we would call this right here? A what? Well, it is kind of rectangular the way I drew it. It doesn't have to be. What do you think? An area, and you're getting closer there. And this is a term you've heard, but this is what we call a plane. So a plane just stretches forever. Now I'll go ahead and tell you, a plane, this is one that you don't need to, you're not going to use this as much. So you don't have to worry about stressing on this one too much. But a plane, how many dimensions does this have? It has 2 dimensions. All right. So when we talk about 2 dimensions, that means any point on here can be defined with just 2 measurements. Okay? So if we look at this, if I've got a point right here and another one right here, I could figure out how far it is in this direction. So I could go left or right on the plane, and then I could go up and down. And every single point can be defined by how far left or right it is, that's 1 dimension, and then how far up and down it is. So when we're working on a coordinate plane like the one you see on the wall over there, it's 2-dimensional, and we only need 2 dimensions to figure out where anything is, or how long any distance is. All right, so that's really what we're getting at. Just 2 measurements are required. All right, a diagram here. I'm not going to try and draw that in the box. So I'm going to draw a plane just outside right here. And I'm drawing it kind of tilted, but it didn't have to be. Okay, and my question for you, how many points do we need on a plane in order to define it? And maybe, that word define. How many points do we need for that plane to kind of be set in its orientation? So for instance, if my iPad right here, if it was a plane, and imagine it stretches infinitely far, I could have it kind of floating around kind of all different ways. So how many points do I need in order to get it to just set in one spot? How many? What did you say? 1? Okay, I heard 4 and 1. Okay, so let's think. If I had 1 point, this corner right here has to stay right where I'm holding it. It can still move around, right? I could have a lot of different planes that go through that 1 point. Okay, so let's say I added a second point right here on this corner. So it can't move from here, it can't move from here. But it can still do this. So it needs 3 points. So now this point is stuck right there, and these two are already set. So 3 points are needed in order to define where a plane is. So when we draw this out, I'm going to go ahead and add a point right here. I'll call it, we'll just stick with A, B, and C. So A, B, and C. You don't have to call them A, B, and C, just any 3 points there. You'll also see this. It's worth mentioning it just because I don't know if you're looking at ACT. There might be things like this that come up. Brandon, go ahead, sit up. Look up here. Okay. You might see something like this given on ACT where they show you a plane, and all that's in there is just like you saw before. We'll go with M again, but it could be any letter. And that's the only thing they show you. So let's talk about the notation for this. You've got A, B, and C. So if you're trying to identify that plane, I'll go ahead and give you this much. It's plane what? What would you call that plane? Okay, we have plane M. We'll do that one first. Yeah, we have plane M. And then you know which one it's referring to. Okay? But let's say it's the one with the points on it. So now we also have plane what? ABC. Could we call it anything else? CAB. That works. CBA works. All right, you get the idea. So if we had a lot more points there, we could just pick any 3 and name the plane based on those 3. And the main thing with all of this is just recognition with the plane. Because, yeah, you might see questions like this, and you'll need to know what it's referring to. Aaron, go ahead, sit up. All right, so the last thing we're going to talk about right here, and then I'm going to give you guys a chance to talk with each other. These are called undefined terms. Well, actually, one thing I wanted to mention is that we don't really talk about planes a whole lot in this class because most of the work we do, we're already working on a plane. So a plane is two-dimensional, perfectly flat surface that stretches forever. There are all kinds of other geometries. Things don't work the same way. If you drew a triangle on a plane, it has certain characteristics, certain properties. But if you drew a triangle, I pulled this out earlier, if you draw a triangle on a sphere, it's going to have different properties. And so you can't use the same rules in both situations. Luckily, you don't have to worry about this because this gets a lot more complicated. Now, these are called undefined terms because, well, the main reason I like to say is because they're not real. How many dimensions do we live in? 3. Everything in our existence is 3 dimensions. I guess if you get into like crazy physics stuff, then you can talk about 14 dimension stuff. But really, everything in our world is 3 dimensions. So if we're talking about something 0-dimensional, 1-dimensional, or 2-dimensional, it's not a real object that we can point to and hold or anything like that. So these are ideas that we can have in our head, but they're not real, so they're undefined. Okay? So these are referred to as undefined because They're not real. Now, every other object that we use in geometry is built on these three undefined terms. Everything else is really just a collection of points, lines, and maybe planes, if you're talking about something three-dimensional. But it's all just built up of these undefined terms. So, with that understanding, what I want you guys to do is I want you to look at the next 5 terms. We've got angle, circle, parallel lines, perpendicular lines, and line segments. And I want you guys at your groups to talk with each other and figure out what the definition of these terms are. Now, I don't want you to write on this page. I'm going to say this very clear. I want to make sure you guys hear it. Do not write on this page that I handed out to you. On the back side of your bell work, either one person for the group can kind of write down the definitions you come up with, or all of you can. But write your definitions down on your bell work, the back side. And then we're going to talk about these definitions. We're only going to get through maybe 1 or 2 of them today. So you might have found that this activity is a little bit challenging because I bet everyone in here can draw an angle, draw parallel lines, draw perpendicular lines, and stuff like that. And we're going to draw those as well. But when you have to think of a way of describing it, of defining it, that's a kind of a different level, a different way of thinking about it. So let's just start with angle. And I'll start with this group in the front right, front left for me. So tell me what you guys wrote down as your definition for angle. Okay, I can definitely see where you're going there. So you got the idea of lines and that there's some kind of angle measurement. And our definition doesn't depend on the degrees or anything like that, but definitely it makes sense. I think a lot of people can envision what you're going for there. Okay, front middle, what did you guys write? Angle.
I think it's wrong, but is that the slant of a line showing distance / measurement?
Okay, so you're getting at there's this idea that it's not just a straight line. There's some kind of angle. You know, you can't use angle in the definition, but there's some slant in there. All right. I know you guys didn't quite get this, but what do you guys think of a definition for angle?
2 points and 2 lines determining degree.
Okay. There's actually something new there. 2 lines. So 2 lines that form some kind of degree. So work with that. Let me just ask this group behind, and then we'll kind of come up with our definition. And if it matches yours, that's great. If it doesn't really match it, that's fine also. All right, so the next group back, what did you guys write for angle?
Angle is some sort of degree in the corner of the plane.
Okay, I can see where you're going with that too. All right, so Riley had his definition kind of dependent on it being on a plane. Okay, so let's come up with our definition. This is one we're going to work with. I'm not saying this is the best definition or the only correct one, but this is one we're going to work with. We're going to call an angle 2 lines. So there we are with 2 lines, and some people were saying 1 line that was kind of bent, but it's really 2 different lines, or what we call rays. And you probably have heard of rays, but if you forgot what they are, don't worry. 2 lines or rays or segments that share a common point. Sorry if you can't read that. If you have any questions on the words up there, just let me know. So they share a common point. So right here, I'm going to erase this in a second. So you don't have to copy what I'm about to do. I'm just going to draw real quick a couple of lines that, well, it looked all right, I guess. What this common point right here in the middle, I'll draw it in red. That common point right there that they share, what do we call that? It has a special name for an angle. No, it's the point itself has a special name. Starts with the V. Vertex. There it is. I heard someone say it. All right. So, this common point that's shared is a vertex. Again, not necessarily a definition that you would maybe call the best, but I mean, it's a definition that works. But I'm going to go ahead and highlight this term vertex because that's going to be really important. Now we're going to go ahead and add a diagram.
Thanks, Emma.
So I've got, these are two rays coming out of the vertex. I've got the angle right here, and I'm going to add a couple other points to this. This is going to be angle Q, or that's going to be point Q right there. There's R, and this is S. Okay, I said at the beginning that probably the most important part of everything that we're doing today, and we're going to finish this up tomorrow, but probably the most important part of this is the notations part of it. So, what would you call this angle? What is it?
Is that correct? Did I finally do it?
Is it that one right there?
Yeah. Did I not finally do it?
No, that would not work.
Why not?
Okay, I'll go ahead and give you a hint in case you guys are sitting there and you've forgotten this from 8th grade. Or whenever you did, for a lot of you, you covered this in your 8th grade. Not everyone did. So you start off with that angle symbol, and then what comes after that? Angle what? QRS, that works.
It is.
What else could we call this? SRQ works. Is there any other name that works for this? All right, we have QR. All right. It turns out actually these are the only names that work, with one exception I'll tell you in a second. But what do you notice about both these names? R is in the middle, and what is R? The vertex. This is the key takeaway. This is what's going to go in that next box. It says example explanation, but this is where we just give more, kind of the main takeaway. The vertex must always be the middle point in the notation. So the vertex must always be the middle point in the notation. I'm going to underline that. Go ahead and underline it. I have a highlighter here on my iPad. If you've got it, you can use it, but otherwise just underline it, make sure it stands out. All right, is everyone? Okay, now I wanted to emphasize this one especially because this is probably the biggest thing that will make some of you guys lose points later in the year. You're going to have to write down angles as answers for certain things that we do. And if you don't write the angle correctly, I will count it wrong. So you really need to understand this notation. I'll give you guys more practice with it. But this is going to be really, really important. All right? Now, I will just add as just an extra little thing here. You could also refer to this angle. It has a third name. You could call it angle R. But call it by just the vertex, you have to be very careful here. If you've got another situation, I'll draw something right here. And you don't have to draw this. But if you've got a situation like this, or let me do it a little differently. If you've got an angle like this, but it's got a third line, and this is point R, you can't call any of these angles point R. Like this one is not angle R, because angle R has multiple angles coming off of it. But in the example that we drew, there's only one angle. So it's fine. Do you see the difference there? Okay. So this one has 3 different angles coming off of it. All right. So just keep that in mind. Be very careful. And for the most part, I'm just going to expect you guys to write all 3 points. Makes it where you don't make as many mistakes. Okay. So there's angle. Now, let's talk about circle. And we need to get a definition for that. I left off right here, so let's go to the middle group. What did you guys write for circle? A line that bends to connect to itself? Okay. I see where you're going with that. Now, a line is straight, but let's just say this also kind of bends to connect to itself. And is that a circle? So I am going to kind of show the flaws in some of these definitions. It's not to make you guys feel bad or anything, but it's like to help us come up with a better definition. Yeah. So what about you guys? What did you come up with for a circle? Two-dimensional sphere. Actually, there's a lot good there. So you said two-dimensional sphere. One problem with calling it a two-dimensional sphere is that we don't know what a sphere is. We have to define what a sphere is now. And let's just get one more definition, because this definition is kind of a tricky one, but let's just go back middle. What did you guys write? A shape that has no sides and angles. And I get that a lot. And that's true. There are a lot of shapes that don't have sides and angles. So while a circle is one of those, a lot of other things are as well. So let's... All right, let's not be talking. So let's go back, and I'll go ahead and write down. Well, let me draw a circle real quick. And let me come back here. So I'm going to draw a circle, and I want to ask you guys. Let's say this is a perfect circle. I know it's not. And we have this point right here in the middle. What can you say about all these points on the outside of the circle in relation to the middle one? They're all the same distance. So this is really where we're going to build our definition off of. So that center point right there. So knowing that, let's come back and I'll just write it in. Okay. So a circle is the set of all points I'm going to leave a gap, and we'll see why in a second. The set of all points equidistant and don't worry, you include that gap on your definition as well, because we're going to fill that in. The set of all points equidistant from the center point. Now that term, I'll give you a second to write. The set of all points equidistant from the center point. So that word equidistant is probably a new one, but it's also probably one that you immediately understand. What do you think equidistant means?
Equal distance.
Equal distance. There you go. So it's a term that you'll be exposed to from time to time. And luckily, it's one that means exactly what it sounds like. So I'll just kind of write that on the side here. It means, if I can write, equal distance. Okay, so we've got this definition, the set of all points equidistant from the center point. Now, I'm going to try and show this up in the air. It's going to be kind of a difficult concept, but maybe someone will be able to catch on. This is not our total definition. That's why I left a gap there. We're about to add something. So I've got a center point, and we're trying to come up with a circle right here. And all these points should be equidistant away, but our definition doesn't define a circle. It defines something else. Can anyone think of what that defines? So let me ask the question a different way. Are these points that I'm tracing right now, are these the only points equidistant from this one?
No, all of them.
All of them, not just in this circle right here, but all of them going around.
A sphere.
In three. This is a sphere. So we just defined a sphere right here, accidentally. So we're going to add one more thing so that we get a definition for a circle instead. The set of all points on a plane. That are equal distance or equidistant from the center point. Okay, we're just going to add one more. We'll just add the diagram, and we'll pick up there tomorrow. Or no, we can do notation as well. So in the diagram area, let's go ahead and draw the best circle you can.
That is a pretty nice circle.
And you need to have a center point, so draw that as well. And we need to label that point. You can call it whatever letter you want. I'm going to call mine point B. Okay. And we talked about a circle is a set of all points equidistant on a plane from the center point. What do we call that distance right here?
The radius.
The radius. So I'm just going to put an R there for radius. I'll just write that out too. So the radius is really important, and the center point is really important. If you have those two pieces of information, you have everything you need to know about a circle. Okay, so if we're trying to talk about this particular circle, we drew a circle, this circle with center point B. So this is going to be circle B. The only thing you have to write down is what the center point is. And there are times, and this is something that you'll see. I'm never going to make you write this out, except for right now. But you might see some things if I give you certain handouts. I don't know if we'll see it all, but every once in a while they'll use this notation. They'll draw a little circle with a center point, and then call it B. So just be able to understand what that's referring to, but we'll always just write out circle, whatever the center point is. All right, we'll pick up from there. We'll talk about this more tomorrow and finish that out.